Hey everyone, in this video we will learn how to teach a car how to drive itself around a racetrack using machine learning, and in particular a technique called convolutional neural networks. Ooh. This is a project that I initially did on the Udacity self-driving car nano degree, and I truly really enjoyed it a lot. So I wanted to share how I did the project and some of the really cool things that I learned while doing it. Okay, so let's start by showing you one of the tools that Udacity provides for this project. It's basically a simulator, and when you start it up, it's kind of like a game. It's done in Unity. There's two modes. There's training mode and autonomous mode. In training mode, what you do is you basically just drive around the track gathering data. Okay, so first let's step back a little bit. So this is how this is going to work. What will happen is we will drive around the track once or twice, and then using that data, we will train a model on a different computer that has GPU acceleration. We will train a model and then go back here to autonomous mode. We will run the model, and then this car will drive itself around the track using just the model that we used. So that's pretty cool. All right, so first part, let's make a new folder here called data. So the first thing that we're going to do is the microphone off. Should be good. Okay, so the first thing that we're going to do is to drive our car around the track and record the data. So here we go. Record desktop data. Select. Okay, it's recording. So let's drive. Wait for speed. Dun, 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 dun. Just a little bit more. Okay, we have now completed one lap. This thing, I think it's enough. So now we will just redo the entire track while capturing the data, and then let's see what happens after. Okay, so now we have the data saved. So this is how it looks like. There's two folders here, driving log and a set of images. So if we open this one, it's a CSV. So it's just a CSV. We basically have on the first, okay, so on the first column is an image, is the path to the center image. Then on the second one, we have the path to the left image, then the path to the right image. There's four other values, which is basically the steering angle, the brake, and the acceleration. It's 0, 1, 2, 3. It's the third or the fourth parameter. I will have to find out later on. Okay, so maybe delete this. Okay, so what does this left, right, center mean? Okay, so let's look a little bit at the images. Okay, so that's how it looks. Okay, that's one image. The next one. Okay, so here's what the okay, so here's what the actual images mean. Imagine, so this is what we capture from the camera, and this is kind of the car right there, okay? So just imagine one image is from the left bumper, so it would cover the first image from the left bumper would cover that part of the screen. The second image, which is the right bumper, would cover the other part, which would be this one. And then there's a third one, which is the center image, which will capture that part right there. So that's what these three different images mean. Okay, so what do we do now? What we do now, we basically zip them up. Okay, compress data. Okay, and as you notice, I have two terminals. Open here. The bottom one is my local map. The top one, this one, is just a local Ubuntu box that I have here next to me. It's because it has GPU acceleration. I can train models faster. So the first thing is to copy. So copy desktop. Now, if I go in the home directory, okay, as you see, we have this file in here. We can go now back to documents, behavior, cloning, and what do we call this one? Okay, so in here I already have a data, so I'll just move this one temporarily. Data, and I'll move it to data backup. Okay, and now copy from the home directory data.zip here and unzip. Okay. Okay, so now I have basically this new data directory. Okay. Okay. First, we're going to train the model using a very simple regression network with just one node, which basically what we'll do, it will just take the images and try to infer the steering angle from those images. So, without further ado, let's do this. Train, simple. Okay, so first we need, what do we need? Let's see. We need CSV to open the CSV file. We need, we will use CV. We will use OpenCV for some image manipulation, and numpy and p. Okay, so what do we really need to do? We basically need to get the lines from the CSV file. Then we need to get the images, place them in arrays, and the third one, augment the images. We don't have that many images, so there's a lot of techniques to augment them by flipping them and doing all sorts of cool stuff. And lastly, train the model. Okay, so first step, get the lines. So, okay, just have an empty array here. So I am just remember, okay, we have this set up locally, data driving log, I think it was called. Yeah, driving log dot CSV, CSV file. Okay, then we have a reader, CSV reader CSV file for line reader. So okay, so for each line, that's done. Okay, so now we have the lines. So now we basically read all the lines. We can actually check this and do something like print line 1. Let's see how it looks like. Train simple, train simple. Okay, so line 1, that will be basically the second one. And we have the data here. And my images. So that would be this one. 950, 950. So okay, that's the index 1 array of the line. Okay, train simple. Okay, then we continue. Get the images. So next part, get the images. Okay, we need two arrays, images and measurements, and then okay. Let's print something to know that something is happening. Okay, what we do know is we're setting this correction because it will just help train the model better. It works without it, but it's just better to have it in this case. So for each line, what we're doing is in range 3. So what we're doing, we're getting the images. Okay. I hate tabs. Source path equals line. File name equals source path. Okay, when we load the image, we have to basically convert. OpenCV loads it into this weird format called BGR, which basically is blue, green, red, and we want to convert it again back to RGB. So what we're doing is cv2.cvt color image, cv2.color BGR to RBG. Oh, this is confusing, I know. And then we continue images. Let's just run it till now, see that it works. Train simple. So now we have the data loaded into memory. Okay, next step that we are going to do is to augment the data. So the images that we have here, let's see some of them. The images are, okay, so this is like a left turn, and it has a certain, it will have a certain steering angle. So what we can do is augment this by flipping it to the right and negating the steering angle. So now we have two images, one going left and one going right with opposite steering angles. So let's go ahead and do that. We will do that like this. Where are we? Train simple images. Okay, so we are augmenting this, augmented images and augmented measurements. And we'll do this for image, measurement, and images, measurement. I love zip for Python. I wish other languages had default libraries like this. Augmented images that append image, and then augmented image that append. So all I'm doing is just taking one image and its corresponding measurement from the normal array, and now we're augmenting them. So augmented images that append, and then cv2 flip image one. So it will just do a horizontal flip of the image, and then augmented measurements that append measurement times, and we're just negating the measurement. That's it. Let's just test that it works. Flip. Oh, image. Okay. Flip. And I'm trying to flip the entire array. Ta-da! Okay. Okay, and then the last step is to actually train the model. Okay, so first, like I said, we will be using just a simple regression model. And we have, okay, so I have the training data, NP array images, because Keras uses, okay, so for training this, we're using TensorFlow, but on top of TensorFlow, we're using another library called Keras. And Keras needs a NumPy arrays to be passed to it. So that's what we're doing right now. We are changing from the image array to a NumPy array. And the next one, train equals NP array measurement. Okay, so so now we imported everything we need from Keras, but in the beginning we will just do a very simple regression network, which what it does, it just tries to predict the steering angle based only on the image with one neuron. So our image is just an array that looks like this. Okay, and from that array, based on certain functions and weights, during the training, we'll try to predict the steering angle, which is just an integer. So the weights, so just because it's a simple network, those will be the pixels, the weights would go in here. This is our neuron, and that will just predict just an integer between -25 and +25, which will be our steering angle. The topic of neural networks is a very deep one, so there are other videos, and I will try to make some videos explaining the intricacies of that. But for now, let's just stick with using a simple network to train this. Okay, so model. Okay, so what does this mean? So into a sequential model, and then we're just adding one flattened layer, and the input shape is basically the size of our image. So there's 160 by 320. It's basically taken from the image details. This is 320 by 160. In Keras, when you put this, you have to put it the other way around, and 3, it's because there's 3 channels on it. And then dense, it's basically we're just looking for one output neuron. And then what we do model.compile. For a loss function, we will use mean square error, and an optimizer, we are using Atom Optimizer. And then model, I think the final part, the training data for the images, then the images, the measurements, validation, split. This tells Keras to just split the entire data into 20%, 80% real data and 20% validation data. So we're shuffling the data beforehand just so that the algorithm doesn't just learn the answers, and number of epochs, we'll just set it to 4, so just 4 epochs. We'll run everything 4 times, and then we're going to save it. Model dot save model, very simple dot h5. Okay, so let's run this. So if everything's, oh, there's no attribute compile, okay. Compile model dot compile. And be epochs. Dun, 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 dun. Oh, here we go. We're training our model. Nice. So I have the model here on my Ubuntu box, and I'm going to copy it on my Mac. All right, so now let's copy the model to my MacBook and then try it out and see what happens. So copy 168.0.20, and I need to grab it from here. Oh, I put double slashes, that will not work. Okay, slash. What do I call it? A model very simple, I think. Model very simple H5. Okay. Very simple 5. And I want to copy it here. Input password. Really? Oh, model. Okay, so now I have the model here, and now I am going to run it. Okay, so if everything went well, we should see the car driving pretty poorly, but driving nevertheless. Oh, there you go. So as you can see, it's driving. It's trying to do stuff, but it's just, oh, there you go, went off the road. Let's try again. Autonomous mode. It's pretty fun. All right, here we go. Let's see if we can make it. We can't even make it past this corner. All right. Okay, so let's close this for now and use a better network. Okay, so what is happening? We're just using a very simple network, and because the pictures are pretty complex, if we look at the pictures, there's a lot of stuff going on in here. It's pretty hard for just one node in a network to properly predict the steering angle. So what we are going to use, we're going to use this thing called, we will use a convolutional neural network. So let me try to attempt to explain a little bit what a convolutional neural network is. Now, this is a very complicated subject. These are courses in university that explain this thing. So this will be a very, very brief kind of idea of what it is. Okay, so if I draw a picture, basically a series of pixels, okay? So this is how the computer sees an actual image, okay? Now, let's say these pixels, they have values because we look at colors and intensity and so on, so they will have some values. But let's simplify them a lot and say, 2, 1, 3, 4, 6, 1, 0, 1, 2, 3, 3, 4, 1, 0, 1, 0, 1, 1, 0, 1. So it will look something like this. Okay, so now what does convolution mean? Convolution means you set a certain kernel. In this case, let's say we set it 2 by 2. So we will set a kernel. So kernel, that's 2 by 2. So we'll set like a 2 by 2 kernel. Yeah, this is backwards. That's okay. We'll set a 2 by 2 kernel, and basically what that means, we will take like a 2 by 2 square in here, and then we will move it, and then we'll take the values from here. We'll make some kind of average or sum or whatever, and then we'll move here and then here and so on, and move down and so on. And that's how we come up with the new image. Okay, so let's say if we do a 2 by 2, then let's say our resulting image will be, let's say 1, 2, 3, 4. It will be a 4 by 4. Sorry, it will be a 2 by 2. Okay, so if we do our convolution, what we do is we will take this square here that has the numbers 2, 1, 1, 2, and based on certain algorithm, in this case, let's take the highest number. Let's say this is the highest number. So what's the highest number between 2, 1, 1, and 0? That will be 2. I have to write it backwards. This is so weird. Okay, so we have 2 in here. Then we move on to the next one, where we have 3, 4, 1, and 2. And in that one, the highest one is 4, which looks like this. So we have 4, 2. Then we move on to the next one. We have 3, 4, 0, and 1. And then this one will be also 4. And the last one, 0, 1, 1, 1. So we will have a 1. So our next layer will look like this. And then you can just keep going in many, many layers like this, as many as you want, really. And that would basically, that's how a convolutional neural network works. Then you just connect them and you have an output at the end. So looking at the video here, this will be the architecture. It starts with the input layers. You do some kind of normalization on the images. Then you have a bunch of kernels. In this case, they're using 5 by 5 kernels. And you just have a bunch of them. Then you flatten them at the end, and you end up with the vehicle control layer. In our case, with just one. So that's what we're going to implement. So simple. So let's comment out this. And do our convolutional neural network. Actually, we will use the same mean square and the optimizer. Okay. Now, all of this I worked out, of course, before the video, so I'm just kind of copying them from another screen. Just so you know, you don't just come up with this. You do a lot of trial and error. So let's see. Model. Okay, so we still do sequential model, and then we do add. So now we're doing cropping 2D cropping 70, 25, 0, 0. Let's shape. Okay, so first thing that we're doing is we're cropping the image, and the reason why we're cropping it is because we don't actually care about this size, so we're cropping about 70 pixels from the top, something like that, and then also 25 from the bottom, because at the bottom, see, there's the actual car hood, so we don't want that. So it's about 20-25 pixels at the bottom, so that basically will leave an area of interest of about this size where all the magic will happen. So that's what our first layer does. Second one, we'll add a custom layer to normalize the pixels. So add. Okay, so now we created our network, and if everything went well, we can retrain. Okay, so we got it to work right now, and it's training. So after this is done, we will copy the model again and run again the simulator and see how our car drives. Okay, so now we're done training this new model. We call it model complex, I think. Yep. So now we're going to copy it. We are going to copy it, model complex. Copy it here. All right. Now let's start the simulation. Oh, there you go. We started moving, and okay, the car is going slow because it's set to go maximum of 9 miles per hour. But as you can see, it is much better than the first attempt. And this whole thing was done just with one lap around the track, and only with just augmenting the data only once in one direction. So it's amazing how much you can achieve with just this simple convolutional neural network for this kind of exercises. So let's see how it does. Going around the more complicated stuff. My laptop is running very slowly right now, also because I'm recording the screen. So because of that, I'm not sure if we're going to lose some frames or not. But there we go. We started turning into the corner, so it's pretty cool. Let's see if we can go over the bridge without any issues. And basically this is how you get a car to drive itself around the track using just machine learning and this architecture called Convolutional Neural Networks. Thanks for watching. I hope you enjoyed the video. I will put all the links below in the description, especially the link to the Udacity course where I got this project from. And please, if you have any comments, uncertainties, there's a lot of detailed topics that I haven't covered in here, like the neural networks and the convolutional neural networks in details. These are great subjects. Please comment, ask questions if something is unclear, and look forward to the next video. Bye bye.